Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad, India. In this session, we are going to study the centroid of a symmetrical and unsymmetrical of various sections. We are going to calculate, including the simple figures to the composite planes. So let us recapitulate. In the previous sessions, we have studied what is the difference between the center of gravity, centroid, and center of mass. Here, the center of gravity is the point through which of your body is a point of your body through which the weight of the body is passing or oriented. And in the case of centroid, is related to a plane figures. In the case of plane figures, it doesn't have a weight. What it will have is area. The total area of the plane figure is passing through the point is known as the centroid. And coming to the center of mass means again it is the point of at which the total mass of the body is assumed to be concentrated. So the centroid, the center of gravity, and center of mass is denoted by the letters either CZ or simply G. Okay, and here in the slide we can see some of the figures like rectangle, triangle, and circle. And the rectangle is having for the rectangle, the centroid is by the joint of two diagonals. The joint of the two diagonals intersection is known as the centroid or center of gravity. Here, centroid is the plane figure. In the case of the triangle, based on the reference axis, it is symmetrical about axis y. That's why it is passing through the the centroid will be on the symmetrical axis, that is yy here. So the centroid lies, so bar x equal to 0, whereas bar y is h by 3 from the base, and 2h by 3 if the reference axis is provided is at the apex. And whereas in the case of the circle, the center here, the reference axis are passing through the centroid of a circle. That's why bar x and bar y are zeros. So this is a line figure, and we have solved some of the figures. Some of the problems also we solved. Here, either find the centroid of a T section. The T section is symmetrical about axis y, and it is unsymmetrical about axis x, horizontal axis. So here it is symmetrical. If we find out simply the centroid, centroid means we have to know whether the figure, the plane is symmetrical about any axis or not. If it is here in this case, the T section is symmetrical about axis y, that's why bar x equal to 0. And what to be calculated? The calculated is bar y. What is the bar y? The expression is that to calculate bar y is a1 y1 plus a2 y2 upon the sum of areas, area 1 and 2. That's section 1 and it is section 2. So 100 times 100 by 30 millimeters area is the rectangular section. And what about the another section 2 area is from here 150 minus 30, 120 times 30. Substitute back here a1 and a2. What about y1? The meaning of the y1 is the distance from the reference axis. Is the vertical distance from the horizontal reference axis to the centroid of a section 1. It is G1. And so here it is G2. Okay, from G1 to here the distance is y1 to the reference axis. From section 2, G2 to on the reference axis, it is y2. So how can we know y1? Y1 is the distance from here 120 millimeters. Okay, 120 millimeters plus 30 by 2, that is 135. 120 plus 15, 135. Y1 equal to 135. And what about y2? Off of the rectangular section of that is 120 by 2. That is y2 equal to 60 millimeters. Substitute A1, A2, Y1, Y2 in this derived expression of the bar Y, then you get it, the bar Y. That bar Y is obtained, here it is, the bar Y is 94.1 millimeters. So X bar and Y bar, the point, the location of centroid of a T section is bar X equal to 0, bar Y equal to 94.1 millimeters. So where it will be, it is on the axis, symmetrical axis. On this location, it is around, the G2 is 60 millimeters, here it is 94.1 millimeter. Okay, thus we have to calculate centroid of symmetrical sections. Okay, and here the find the centroid of a channel section we have already calculated in the previous session. Please go through that lecture so that you can understand the channel section, how to calculate. Just a glimpse here, it is I section. So let us coming to the briefly about I section. This I section is having two parts. Actually, there are three rectangular sections are there. The horizontal is known as the flanges. If we consider it as a section 1, is the flange 1. Section 2 is a flange. What about section 3? The section 3 is known as the web. Section 1, here it is flange. Section 2, what about section 3? The section 3 is web. So I section is having two flanges, one web. The cross sections, here it is the rectangular, and here the bottom flange is having the cross section of 300 millimeters times 100 millimeter, that is A2. A2 equal to 300 times 100 millimeter, and A1 equal to 150 times 50 millimeters, and A3, that is 300 times 50 millimeters. So it is symmetrical about, first of all, it is symmetrical about axis Y, vertical axis. So bar X equal to 0, it is symmetrical about vertical axis. So bar X equal to 0. What to be found? To be found bar Y. What is bar Y? A1, Y1 plus A2, Y2 plus A3, Y3 over the sum of A1 plus A1, A2, A3. We know A1, A2, A3, and what about we need Y1. How to calculate the Y1? Consider the reference axis is the horizontal bottom. This is the reference XX. What is the Y1? The CG, G1 lies here, G2, G3 lies somewhere in the middle of 300, and G2 lies. Now the distance from G1 to XX. G1 to XX is known as G1 to XX is known as the Y1. The value Y1. What is the Y1 here? That is 100 plus 300 plus 50 by 2. Y1 equal to 100 plus 300 plus 50 by 2. That is 425 millimeters. What about Y2? The Y2 is the distance from G2 to XX. This is Y2. The Y2 is 100 by 2. That is 50 millimeters. And finally, Y3. Y3 is the distance from G3 to XX. The G3 is half of 300. This is 100 millimeters. That is 100 plus 300 by 2. That is total 100 plus 150. That is 250 millimeters. So substitute these values of A1, A2, A3 and Y1, Y2, Y3 in the derived expression. Here it is bar Y. Then the bar Y will be obtained. The bar Y is calculated here it is as 160.7 millimeters. So let us, what is the bottom flange area? That is A1. 300 times 100, that is 30,000 square millimeter. Because it is a rectangle, so rectangle is, what is the area of rectangle? Length into breadth, that is 300 times 100. What is the y1? Yeah, they consider it as a bottom flange here. We consider as A3 section 2 we considered, and the bottom flange is the section 2. And here it is section 1 top flange, the section 3 is web. So web is considered as 3 part, that is section 3 here. What about A2? The A2 is, what is the A2 here? The A2, where is A2? That is the web. Web is the 3 section. We consider, don't get confusion, A3 and Y3 we consider, here it is notation. If you follow this notation, you can consider it as not only section 1 is the top flange, you consider any section as the section 1 and go through it. So bottom flange is considered in this, solved as a bottom flange is the first, that is A1 section 1, web is the section 2, and the top flange is section 3. So you can consider any manner, but find out the procedure is that A1, Y1, A2, Y2, A3, Y3, and substitute in this expression of the centroid expression, that is A1, Y1 plus A2, Y2 plus A3, Y3 by A1 plus A2 plus A3. After substitution, we'll get the value, the calculated value is 160.7 millimeters. That is x bar, y bar equal to 0, 160.7 millimeters. This is the centroid location of this I section. Here, the I section is one line of symmetry, single line of symmetry. Okay. Point is that this is symmetrical about vertical axis, so bar x equal to 0. Now, the question is that if the I section is symmetrical about both axis x and axis y, it is symmetrical about, exactly, that means the flanges 1, here we can bottom flange and top flange both are in equal cross section, area is remains the same. Suppose here it is, I'm considering as 300 millimeters, and here it is 100 millimeters, the web thickness, the flange thickness of the top bottom flange. The top flange is also 300 millimeters length and 100 millimeters thickness. And the web height is, again, you can consider it 300 millimeters length, and here the thickness is 50 millimeters. It is symmetrical about, the point is that it is symmetrical about both horizontal and vertical axis. It is symmetrical about horizontal and also symmetrical about vertical. Now this reference axis, it is symmetrical about both the axes. Are what about this is CZ, the gravity, the centroid, the location of the centroid. What is the centroid of this section? What is the centroid of this section? Just no need to calculate bar x, bar y and all. Just by looking at the picture, we can tell directly. The symmetry, the centroid distance is 0, 0. Why? The reference axes are passing through the centroid of the I section. Here the reference axes are. Okay, simple. The passing through that bar x and bar y. Suppose, yes, and we can tell another manner, the bar x, it is symmetrical about axis y, bar x equal to 0. Now, the point is that the bar x and bar y. Suppose, another question. It is here, the figures are given. Alright. It is symmetrical about axis x and axis y. It is symmetrical about both. There are two lines of symmetry. And the question is that if the reference axis were given here, this point and this point, this axis x and axis y. In that case, what is bar x and bar y? The bar x and bar y is, yes, the bar x equal to, it is 300 it is 300 mentioned here. The bar x equal to half of the length of the section, that is 300 by 2. The bar y, vertical distance, bar y equal to half of the vertical length, 100 plus 300 plus 100 by 2. Total how much distance? 100 plus 300, 400 plus 100, 500 by 2. That is 250. So bar x and bar y distances are 150 and 250 millimeters. That means it is located here. Again, the location comes. Bar x and bar y location. So it is 150 and it is 250 millimeters. Now these are the location of the centroid of two lines of symmetry section, that is the I section here. Okay, and one more thing is that very important, if you want to follow some of the things like it is H section is there, how to calculate the H section. The H section, calculation of the H section is, suppose H section is given as with the different dimensions. Suppose if the H section is given as with the different dimensions, how to calculate the centroid of this H section? Okay, we follow the both equal sections. This H section is symmetrical about both axis x and also axis y. The dimensions mentioned for this here it is 300 millimeters and here it is 10 millimeters thickness. The one of the left flange, and similarly the right flange thickness is 10 millimeters and the length is 300 millimeters. The distance between it is 300 millimeters and you can consider it as 50 millimeters. How to find out the centroid? Okay, we can tell by it is symmetrical about, by observing the geometry, it is symmetrical about both horizontal and vertical axis. Consider there are two different types of answers. If the reference axis is at the center is passing, then bar x and bar y equal to 0, 0. If the reference axes are at the sides, bar x and bar y, suppose the vertical axis and here it is the horizontal axis. Consider these are the two reference axes. If you consider these two reference axes, how to calculate the centroid? For this you have to calculate what is the distance. The total distance, horizontal distance of total length is how much? That is bar x equal to the total distance by 2, that is 10 plus 300 plus 10 by 2. Then it will come out as how much? That is 320 by 2, that is 160 millimeters. Whatever bar y, it is symmetrical about vertical axis. The bar y is the symmetrical about vertical axis also. So bar y is the vertical distance. That is the vertical distance, total distance vertical is 300 millimeters by 2. How much it is? 150 millimeters. So we calculated it is symmetrical about bar x and bar y. This is the one of the method to calculate centroid of two lines of symmetry planes. Observe it here, it is 160 and 150 millimeters. Another method we are going to calculate, second method or another method. This is the first method we calculated. The second, another method, alternative method is that bar x equal to a1 x1 plus a2 x2 plus a3 x3 by sum of a1, a2 and a3. And bar y calculation, the bar y equal to a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3. Again, what is a1? Yeah, consider it is the section 1, left flange is the section 1, the middle web is section 2, and the right flange is section 3. So we have to know it, what is a1, a2, a3, x1, x2, x3, y1, y2 and y3. After knowing those values, if you substitute in these expressions, bar x and bar y expressions, the same answers to be obtained. Alright, so how to make it? Let us begin with the table A1, A, area, A, X and Y. Or we can make it as section 1, 2, 3. That means you can understand better. X1, X2, X3. That is section 1, section 2 and section 3. This is a table also you can follow, so that easily you can calculate. This is the section portion. What about areas? Area A, small a, and bar X and bar Y. Sorry, not bar X, that is X and Y. It comes under section 1, it becomes x1. It comes to section 2, section 2, it becomes x2. Comes to section 3, it becomes x3. Area similarly, a1, a2, a3. What is the a1 here? A1, area of section 1 is a rectangle 300 times 10. That means 3000. It is 3000 square millimeters. And here it is millimeter and here it is millimeter. What about A2? It is 300 times 50. That is 15,000 square millimeter. A3 is a rectangular section that is 300 times 10. That is 3000 square millimeter. Now coming to bar X, that is X1. Sorry, in X millimeter, that is X1. What is X1? Horizontal distance from vertical reference axis to G1 to section horizontal distance. That is 10 by 2, 5 millimeters. Next, X2. What is the X2? From G2 to what is the distance? X2 means 10 plus 300 by 2. That is 160 millimeter. X3. Horizontal distance from here. What is X3? 10 plus 300. That is 310 plus 5. 10 by 2. 315. Next, what is the Y1? Y1 means from horizontal axis to section 1, section 2 and section 3. What is the Y1? Distance from G1 to vertical distance of from horizontal axis, vertical distance. G1 to vertical distance to XX. That is 300 by 2, 150. What about Y2? Y2, this is the distance of G to here, G2 to this vertical distance. Again 150 millimeters. What about G3? Vertical distance, again 300 by 2, 150 millimeters. Substitute now. The question is that for you to do the homework, complete. Substitute A1 3000 and what about X1 is 5, A2 15,000, X2 is 160 and A3 is 3000 and X3 is 315 and A1, A2, A3 substitute. Similarly, in the expression of bar Y, A1, A2, A3, Y1, Y2, Y3, then the answer will be obtained as 160 millimeters and 150 millimeters. 160 and here it is 150 millimeters. So bar X and bar Y is, bar X is 160 millimeters, bar Y is 150 millimeters. So the location of centroid for this cross section is this 150 on this axis, and from here 160. Okay. Now one of the conceiving is that coming to closer answers here, 160 and 150 I told you here. Coming to here, bar x 160 millimeters, and here it is coinciding to the centroid x1 and y1. Alright, x1 y1, it is going, the answers bar x and bar y is coinciding with x1 and x2 y2 points, x2 y2 location, coordinate of x2 y2. Now this x2 y2 is the centroid of the section 2. Alright, that is a section 2. Now the why it is coinciding with the section 2? Because this x2 y2, because it is symmetrical about this H section is two lines of symmetry, that is both horizontal axis and vertical axis. This horizontal and vertical, if you fold complete the H section, you fold about vertical axis, and if you fold horizontal axis, this H section, then the intersection point is the gravitational point. So the bar x and bar y is bar x and bar y is the centroid of the whole geometry, is passing through the centroid of the section 2. That is the inference we can conclude in this H section. Similarly, if you coming to H section, if you turn 90 degree, then you can obtain as a symmetrical I section. If you consider the I section, also the geometry, the bar x and bar y is passing through x2 y2. So the two lines of symmetries easily, no need to calculate this. Another method which I calculated here, it is no need to do it. Why? Again you have to count, same thing will be obtained. In the case of two lines of symmetries, we can locate directly, depends upon the reference axis. If the reference axis are passing through the centroid, the both lines, that is intersection point, that is bar x and bar y is 0. That means that is the coordinate begins there. That is 0, 0 coordinate. The reference axes are on the extreme edges, then off of the distances we can make it. By visual inspection you can calculate. So no need to follow for symmetrical sections this another method of the derived expression method, that is bar x and bar y substitution again. Again it comes to, again we will come back to same conclusion of direct geometrical presentation. So this is one of the manner. Now the next is that here we have considered only in this session, so far we consider the rectangulars, how it is rectangle, only rectangle calculations we have done. So by using the centroid, only centroid for the plane figures we have studied here. So the center of, there are two things are there coming to the centroid. Why should we require the centroid? Why should we study the centroid? Why should we calculate? One more thing, mathematically, in the case of algorithms, the centroid is connected to the central distance, is connected to the concept of parallel axis theorem. In order to, why should we do parallel axis theorem? Parallel axis theorem is useful to calculate the moment of inertia, area moment of inertia of composite plane figures. So in the case of parallel axis theorem, that is Ixx equal to Ig plus area times bar y square. Okay, it is symmetrical about x-axis. Iyy, the moment of inertia. What type of moment of inertia? The moment of inertia about vertical axis, yy equal to reference axis equal to Igy1, that is parallel to xx, Igy plus area times bar x square. Here, this is bar y and bar x. What is the bar x and bar y? The location of the centroid of the geometry. Okay, This is called, it is known as the mathematical model. In the case of, if you term as in the case of soft computing, you consider that algorithm, okay, computation model. Now the point is that this is a soft computing model. Now the point is that the bar y and bar x are necessary to calculate the moment of inertia. What type of moment of inertia? Again, there are two types of moment of inertias. Moment of inertias are two types. Number one, area moment of inertia. And next, number two, mass moment of inertia. Mass moment of inertia. Where to use this area moment of inertia and where to use this mass moment of inertia? The unit of area moment of inertia is mm per 4 or meter per 4. Whereas the unit of mass moment of inertia is kg centimeter square or kg mm square or kg meter square, kg square meter. Now the point is that this bar x and bar y is connected to the centroid of the plane figures. So this plane figures, that means connected to area of the plane. This I-axis is area moment of inertia. I-y-y is area moment of inertia about the vertical axis y-y. I-x-x means area moment of inertia about horizontal reference axis. So this I-x-x, I-y-y, okay. What about this I-g-x? Again, area moment of inertia of the axis passing through horizontal axis, horizontal centroidal axis of a simple figure of the geometry. I-g-y means, again, centroidal vertical axis, area moment of inertia of a centroidal vertical axis. So in that manner, what about area of the geometry? Suppose if the composite sections are there, the composite section is having 3 sections are there, section 1, section 2, section 3. Then the total I-x-x equal to I-x-x section 1 plus I-x-x 2 plus I-x-x 3. Similarly, I-y-y equal to I-y-y 1 plus I-y-y 2 plus I-y-y 3. Thus, we have to calculate the total moment of inertia of the geometry which consists of the 3 sections. Okay, in this section we covered, we solved some of the problems of the symmetrical sections, both the symmetrical sections, and also concepts of the moment of inertia. And very important, why we should study concept of moment of inertia? Because what is the use of the calculations of centroid? Centroid is highly helpful, calculations are highly useful in order to calculate the area moment of inertias of various geometries. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.